Precision class. I hope you had a good spring break and that you're ready to get back into it. Dr. Harden has been putting lecture videos up, and this week was my week for lab, so you get to watch me do this through a video, unfortunately. But I wanted to show you the experiment we have going on in this greenhouse. So if you remember, back before spring break when we were talking about different sensors that you can have on equipment and that you can use them for a variety of reasons, and we talked about like chlorophyll meters, like the at-leaf meter that we showed you in class. That wouldn't be measuring technically the chlorophyll content or the SPAD, and you could use those numbers according to research already been done and put into a graph to show whether it's a healthy plant or a non-healthy plant. And so then if you knew you were having issues like a low SPAD number, it wouldn't tell you exactly what was wrong with the plant, but you'd know that there was something wrong, and maybe it was fertilizer, maybe it was pests. So to kind of show you a real life example of that, we have set up here these 3 rows of 1 gallon pots, that this first row here is getting just 125 parts per million of nitrogen. This middle row was getting 250 parts per million of nitrogen, and then this third row was getting 750 parts per million of nitrogen. If you're curious, usually you're somewhere between these first 2 rows, like 200 parts per million of nitrogen is usually recommended. So the 750 is going like way up beyond, and I was thinking we might see some toxic effects, which kind of looks like we can see. And we have both soybean species and alfalfa species. So those were the 2 that I grew. There are 3 of each, and so when we talk about replications and the experiments and the trials, all right, well, you'll see why at least 3 replications are needed so that you can get a good average across them. But if you guys could have been here for this lab, then you would have been taking these measurements, but now you get to watch me do it. So we're going to be taking measurements of height, which is really just using a simple ruler, putting it at the base of the soil, and measuring the top of the plant there. So I will be recording all of this data, and in a second video, when I'm actually at my computer, I will give you guys that data in Excel, and I will show you what we want you to do with it. So we're going to be taking plant height, and then we're also going to be measuring the chlorophyll content. So again, this is a slightly different sensor than what we showed you in lab. The one we showed you was called at-leaf sensor. This is a similar one, just made by Apogee Instruments. And I'm also going to put up a quick video of the guy that developed this instrument. He has a YouTube video that's really, really interesting, so I'm going to post that as well. But it's really simple to use. You've got an on-off button down here. You turn it on, and the very first thing it wants to do is be calibrated. So you hit run, you hit measure, and it says that it wants to calibrate it. So clear out the sample area, which is right there, hold down the arm, and it says okay. So if you remember, again, these sensors, they have at the base here, below where you're going to be putting the leaf, all right, that's the actual sensor that's going to be recording the light that comes through. And up above that silver arm is what's sending the red light and the near infrared light. So this arm is sending that, and then we have the actual sensor below that will be receiving what light's transmitted through the leaf, and it uses a simple equation to basically give you an answer for chlorophyll number. So to show you again how easy this is, you put that leaf right there in your spot, hold the arm down, it measures it within seconds, and it gives you this. This is technically chlorophyll content. It's micromoles per square meter, so 18.8. And we'll say versus a soybean that had less nitrogen, all right, slightly lower, 18.3. But we're also going to talk, well, the measurements I'm going to do are going to include measuring the chlorophyll content for lower leaves. So we'll take some lower leaves down here, and then mid-leaf range, and then upper leaf range, so that I can show you, again, the variability. That's a big word that we talked about in class a lot, variability. So, you know, if you had a sensor on your equipment that's just running over your plants, and, you know, most likely hitting the top leaves, but I'm gonna show you that with chlorophyll content, that could be very different up here on the plant compared to lower on the plant. So we're also going to separate out low to mid to high leaves and then plant height. And so with all of this data together, then you're going to get to see not only variability among the plant, but variability among species, so soybeans versus alfalfa, and then the variability between different fertilizer amounts. These have been growing, gosh, I want to say for 6 weeks or so, and you can visually see some issues with the high nitrogen. All right, we've got a lot of, oops, pulled that off, deformed leaves, could be showing toxicity effects. We also do have, because this is a greenhouse, some insect damage. All right, thrips just love soybean plants in the greenhouse. So there is a little bit of insect damage too. But let me go ahead and take all these measurements, write them down on a sheet, and then, like I said, after this, watch the video I post from Bruce Bugbee and Apogee Instruments on this, where he explains it a little bit better what's going on with this equipment. And then my next video will be, again, at my computer with all of this data input, and I will show you what we want you to do for lab this week. So stay tuned.